Hello, everybody, and I'm here today to talk about tracing a cloud-native database, specifically ClickHouse. And of course, since we're talking about tracing, we're going to be talking a little bit about OpenTelemetry. So with that, let's dive in. This is me. I'm Josh. I am an open source advocate at Altinity. We provide hosting and support services for ClickHouse, which is one of the things that I'm going to be talking about today. Our lawyers wanted me to point out that we are not affiliated with ClickHouse Incorporated. We are just humble open source contributors. So I give a lot of talks about observability and introducing OpenTelemetry. And kind of one of the first things I talk about is how overwhelmed we are with logs, right? Logs can be sort of a needle in a haystack situation where we're just always digging for that answer. But if we think about it, logs are sort of the fundamental building block of monitoring and observability. So if we start with a humble log like this, right, this is sort of familiar to all of us. This is a typical request log. Some of the properties that you'd see on it, hopefully they'd be in like JSON format or something. But this is hopefully familiar to everybody. If we start to count those things, all of a sudden we can build this, and we have our RED metrics. And if we can count those across our various endpoints, we have a really, really good idea of the overall health of our system and the various endpoints and surfaces that are connected to each other. So that's really cool, but we can make it even better, and that's where distributed tracing comes in. So we take those request logs and we add a parent ID and a span ID to all of them so that we can build these nice waterfall or tree graphs of the actual flow, right? We can have sort of this cause and effect embedded into the actual syntax of the events, or really logs, fancy logs, if you will. So there we have distributed tracing. We now can follow the request flows through our services, which as we get past like N-tier services into microservices becomes really, really useful. And it's also really useful when we're talking about a distributed service, like say ClickHouse. So in my opinion, distributed tracing is kind of the killer app of observability. It lets you understand the complete request flows through a system. You can create a real-time map of system topology and dependencies from those actual request flows, so that's a really powerful tool. You can, as we showed, derive metrics from the metadata on those traces. You're not limited to cardinality the way that you are with pre-aggregated metrics. And you can make your logs and metrics so much more useful by enhancing them with the context of the traces. So that's my short sales pitch for distributed tracing. Really, the solution to open source distributed tracing, if we want to move away from the vendor solutions that sort of first solved the problem, is OpenTelemetry. For those who are not familiar, OpenTelemetry is kind of a lot of things, depending on who you are and how you engage with the project. But at its core, those things break down into three things, right? It's the specifications, it's the actual libraries and tools and implementations of those specifications, and it's the community who's building it all. So one of the key specifications is OTLP, which is the wire protocol that telemetry is sent between services using. Many services are now converging on compatibility with this. Many observability platforms now have compatibility with this. So it's a great way to make your telemetry portable between systems and interoperable between systems. When we combine that with the semantic conventions, we sort of have this universal API for what our telemetry should look like and how it should be transported. And that means that tools like a database can follow these conventions and follow these protocols and have compatibility built in out of the box. When it comes to libraries and tools, there's the language-specific SDKs and APIs. These are the tools that you would actually embed in your code. They're available in all of the programming languages supported by OpenTelemetry. There's the instrumentation libraries. Those are the things that you also embed in your code that sort of connect code libraries that you might be using, like Express or any of the other libraries, right? Those get connected to your OpenTelemetry. The OpenTelemetry collector, which can act as sort of an agent or a gateway, replacing some of the functionality that you might have gotten from a vendor agent or from something like Promtail. And it's the second most active project under the CNCF, which is pretty impressive. It's really starting to become predominant. So this is how all of those things fit together. If you were using this in your own code that you'd written, you'd sort of have those pieces in your code. You'd have the OpenTelemetry collector running somewhere on your node, and then you'd have some kind of backend set up. We'll very briefly touch on that. Let's talk about ClickHouse. ClickHouse is awesome. It's open source. It's insanely fast. It's deployable as a single binary, which is nice and convenient. It speaks SQL, which I'm a huge fan of. You can run it on anything from a Raspberry Pi all the way up to exabyte scale, absolutely massive scale. And it's really, really good at handling high cardinality. In ClickHouse, low cardinality means millions, right? So we're dealing with just completely different orders of magnitude when we're talking about high and low cardinality, which is really convenient if you're lazy. And it also really nicely fits the observability use case. So ClickHouse is actually used under the hood in many observability platforms and products. And it's because of this pattern, right? That telemetry data gets written once and then read many times, hopefully, right? Like if you're actually using it, if you're not using it, maybe you shouldn't have gathered it in the first place. But that sort of fits the way that ClickHouse's merge tree works with sort of these immutable parts that are getting merged in the background to speed up your traces. Your queries rather, right? So this is sort of an example. This is a diagram of how merge tree works. So basically, ClickHouse takes in bulk inserts. So you want to be inserting like 10,000 rows at a time, and I'll talk about some strategies for how you can do that. And then those inserts get stored on disk. They get sorted and stored on disk. And then in the background, they get merged into larger and larger parts on disk that are sorted so that when you're querying your data, it's all laid out nice and neat and ready to be read very, very quickly. So this is how ClickHouse can take queries that would take 1,000 or more seconds on a traditional LTP, OTLP database, and it can run them in under a second. Here's a sort of a more larger view of that happening. So you have these unmerged, freshly inserted parts that are available immediately for query, which is really nice if you're trying to do something like real-time analytics or you want like a 3 to 5 second metrics window. And there are some other benefits. So besides being extremely time friendly, because of the way that data is ordered and sorted on disk, you can just discard entire parts when you're done with them, which allows for easy cleanup. You get very, very robust ETL policies, and you can implement tiered storage so that your archival data is moved to cheaper and slower storage. As I mentioned, you can deal with extreme cardinality. Because the data is all stored in columns, you get very, very excellent compression and things like delta encoding that can make your data fit much more compact on disk. And there's flexible schema, right? You can use things like JSON columns and map columns for sort of arbitrary attributes and tags. So a couple more notes on observability with ClickHouse, and then we'll dive into observability for ClickHouse. If you want to use ClickHouse for storing your distributed traces or metrics or logs from other applications, you can use the OpenTelemetry Collector Exporter. That's a great way to get data into ClickHouse. There are 2 Grafana data source plugins, one from Altinity and one official one. They both have different features. They're both great. There's a Kafka connector for ClickHouse, which if you already have your data in Kafka is a great way to get your data into ClickHouse. There are many observability platforms built on top of ClickHouse. I'll talk briefly about these 3 open source ones. Plasma is a compatibility layer that teaches ClickHouse how to speak Elasticsearch or OpenSearch API language. And then lastly, really exciting is the integration of Iceberg and Parquet. So if you want to sort of turn ClickHouse into a data lakehouse, you have some options for doing that and having really, really cheap storage for as much data as you need. Using it kind of looks like this. You have your OTel collector. It speaks SQL to ClickHouse, and then the Grafana plugin is speaking SQL to visualize the data. So it's SQL all the way through, which is pretty great if you like SQL. So deploying this in production, you'd want to do something that kind of looks like this. You'd have some OpenTelemetry collectors deployed as agents. You'd probably have at least one set of OpenTelemetry collectors acting as a gateway. In Kubernetes, that would mean running in a deployment mode. And those gateway collectors are going to be responsible for the batching and then creating those large, 10,000 row SQL inserts into ClickHouse. And then if we're talking about production, if you're running in Kubernetes, the Altinity operator is the best way to run ClickHouse in Kubernetes. You'll want to have Keeper, which is how ClickHouse maintains state and quorum across its replicas. So you'll want at least 3 Keeper replicas, probably exactly 3. And then you'll want a ClickHouse cluster with replicas. And the shape of that can vary depending on exactly what you're trying to do. But if we zoom out a little bit and look at what a full observability solution would look like, we have a few more components, right? We need the application and SDKs, the host and node agents, those are covered by OpenTelemetry, collection sampling and processing, that's covered by OpenTelemetry, storage gateway, that might be OpenTelemetry again, storage, that's ClickHouse, analysis UI, that would be Grafana, Alerting, you can also use Grafana and Alert Manager or other tools. Or you can use an all-in-one solution like CoRoot. This is one that I'm a huge fan of. It bundles ClickHouse and Prometheus and an eBPF node agent, give you sort of no code, batteries included observability. You can just sort of turn it on and immediately start getting value. So for the kind of like applications that I'm building where I'm just frequently moving from one demo to the next, this is really, really convenient. Some other observability platforms that you could take a look at, Signos is basically like if you would think of most of the functionality of Datadog, but on an open source platform built on top of ClickHouse and OpenTelemetry native, which is really cool. And then ClickStack from ClickHouse Incorporated, formerly HyperDX, which combines ClickHouse with an OpenTelemetry agent and visualization UI that is very flexible and powerful, both for the OpenTelemetry data as well as for any arbitrary data that you might have coming in. Very, very cool MIT licensed offering. So with that out of the way, let's actually talk about observability for ClickHouse, which is what you all came here for. So ClickHouse has a bunch of built-in observability, which I think is really awesome. I think more tools should start adopting this pattern. Observability, in my opinion, is much better when it comes from the tool builder rather than someone else trying to sort of externally inspect and examine the tool with less of a knowledge of how the tool works and less of an ability to change the internals. So some of that built-in observability, we have the metric log, we have a part log, which stores data about the part operations that are happening, those merges that we were talking about. Query log, which is of course very useful if you're trying to understand usage patterns and how they're impacting performance or how the performance of the individual queries is. And then we have the trace log, which is not the type of traces that we were talking about earlier, right? That's actually the stack traces from the individual threads within ClickHouse. And then we do have a table for distributed traces. And it is called the OpenTelemetry span log. And it is built in, it is disabled by default, but you can enable it and it will be created dynamically as soon as you run a query that requires it. So you can enable that either via a sweat setting on an individual query or on an entire user profile. I'm going to share a GitHub repo at the end that has examples of doing it on a user profile. Or you can send it in the request headers for a connection request. This gets a little bit awkward because then if you send more than one query on that connection request, they're all going to have the same trace parent ID. But this is what that looks like if you do want to send that as a header, right? You just basically create a trace hash and then send it using this flag. If you always want ClickHouse to initialize a trace, this is the setting that you set. So obviously that's a probability between 0 and 1. If ClickHouse receives a connection that already has a trace ID, it'll propagate the trace. But if you're just initiating a query like from the CLI or from the REST API, this determines the probability that ClickHouse will start a new trace. Of course, for all of these demos and experiments that I'm doing, we're setting this to 1 so that we can see everything that's going on. So I said demo. Let's take a look at the demo. So here we have, this code is available on GitHub, and I'll share the link at the end. But it's pretty simple, right? There's not actually a lot of code here because really we're just using the built-in functionality of ClickHouse. So we have a Docker compose file. This is a little bigger. And this is pretty straightforward. We're setting up 4 ClickHouse nodes just so that we'll have something kind of interesting to look at. If you're running this on like a smaller laptop or an older machine, you might want to limit this to like 2 or 3 ClickHouse nodes. It doesn't have to be an odd number. It can be an even number. And you'll just need to change the configuration to match the topology that you create. And then we have a single instance of ClickHouse Keeper because this is just a demo. And so that's going to maintain consistent state for all of those ClickHouse nodes and maintain our replicated tables. And then we have Grafana so that we can look at what we're doing, right? And then we have most of the setup happens in shell scripts. So we have this init, which mostly just kicks off setup OTel tables. And this is so that when we're creating our Grafana dashboard, we've already run some queries that had that setting so that those tables already exist and we don't see errors all over Grafana. So this basically just runs through on each node and sets up some schema and then runs some traced queries so that those OpenTelemetry tables will get dynamically created by ClickHouse. So we can look at what those actual tables look like. So besides the tables that are created by default by ClickHouse, our Grafana dashboard is actually powered by some views, which again, you can get in the GitHub repo. So we have these views to calculate durations on the traces. and also to merge the traces across all of the different replicas, because each one is sort of storing its own spans individually, and we need a way to query them all at once. And then what that ends up looking like is we get a very, very simple dashboard like this. This is just using some of the built-in functionality in Grafana for visualizing traces. Um, and you can see we have, some of the example traces that I ran last night, just some stuff trying to get it to talk to all of the different nodes. And you can see on this, if I scroll down, can I scroll down more? Yeah. This one actually hit multiple nodes, so we can see part of the query was executed on ClickHouse 01, and part of the query was executed on ClickHouse 03, and we can see the duration of each of those. The whole query only took 7 milliseconds, so pretty fast, but we can dive in and see what took up all of the time. And we can see how the communication happened across the various nodes, which is really, really cool. And so this is actually being queried directly out of ClickHouse. This is okay as long as our ClickHouse instance is still running. Of course, for observability, we might want to be debugging this in a situation where the ClickHouse cluster is down or not responding properly. So there are different ways that we could export this. ClickHouse can use like an HTTP engine to just export this to an OpenTelemetry collector, or you could have an OpenTelemetry collector with some sort of mechanism or receiver built in to scrape this data. There's nothing off the shelf, you'd have to build that yourself, but I think that would be a viable way to persist this data if it was really important to your debugging. And so that is my demo. And of course up here, right, we can look at any of the other queries that were run. Of course, this dashboard could be made easier to use. We could link these, right, so that they automatically load the parameters and things like that. But for a demo, I think it shows the power of what we're working with and how awesome it is to have distributed tracing built into a tool. And of course, we could combine these traces with an application if it were an application running these queries instead of just me on the console. So that was our demo. In case that didn't work, I have a screenshot. You can see this is a much longer query because we're using Altinity's new project on Talia, which is an integration with Iceberg and Parquet. And so you can see talking to S3 this is running on my laptop, so we're not running in the cloud with a nice fast connection to S3. So this query took 2 seconds, and most of that time was spent waiting for S3 list object calls. A lot of the work that we're doing in Project Antalya is about taking those the results of those list object calls and making sure that they're very properly cached and sort of doing other intelligent indexing so that we need to do as few of those as possible and we can get directly to the Parquet files that contain the data that we need. I mentioned that you could trace this from the client side if you were using this as part of an application. Right now, the supported ClickHouse clients that have OpenTelemetry support built in out of the box include the Java client, the Golang client, and the Python client. So if you're working in one of those languages, you can just turn it on and it will work. If you're not working in one of those languages, then this is a call to action to help improve OpenTelemetry, work on the auto instrumentation libraries for that language, or work on the ClickHouse SDKs for that language and build in OpenTelemetry. The community would love that. Yeah, this is how it all gets better, and this is the beauty of open source. And so my final thoughts, well, distributed tracing is awesome. I think I made that clear. And built-in observability is doubly awesome. More tools should have built-in observability, and when it can be universally compatible with OpenTelemetry standards, I think that is just great. Here is the URL for the Git example code. If you can't read that because it's too small, it's Josh Lee creates /tracing ClickHouse. I promise this QR code just goes to that GitHub URL. And yeah, now there's, I think, time for some questions.